Hello students, how are you all? I hope everyone fine. So in last class we learned 5 different form of equation of plane. I'll just recall once, then I'll continue with the different form of equation of plane. So in last class we learned first form, normal form. Then vector r dot vector n cap equal to d. What is n cap represent? It represent unit normal. D represent length of the perpendicular length from the origin. D represent perpendicular length from the origin, and n cap represent the unit normal. So next second equation or second form we learn is equation of the plane passes through the point and perpendicular to the vector, and remember, for every plane, if vector which is perpendicular to the plane is known as normal vector, remember that. Okay, so when normal vector given and passes through the point is given known, then equation of the plane is vector r minus vector a dot vector n cap equal to 0. So remember, here n cap represent normal vector, no need that its magnitude is 1. Okay, it's just a normal vector andre no vector which is perpendicular to the plane. So remember that. So as a next equation of the plane, we learn the equation of the plane passes through 3 non-collinear points. Non-collinear points andre no the points in a triangle shape. Okay, so if a b c are the position vector of the 3 non-collinear points, then its vector equation is r minus a dot b minus a cross b minus c. So this is a scalar triple product. Cartesian form, determinant x minus x1 y minus y1 z minus z1 x2 minus x1 x2 minus y2 minus y1 z2 minus z1, and like that last row x2 minus x3. Okay, minus the because of the property of determinant, remember that. So remember, this is a vector form, Cartesian form. Okay, I discussed in last class. So next one, intercept form x by a plus y by b plus z by c is equal to 1. And lane x intercept, y intercept, z intercept. Then equation of the straight plane is x by a plus y by b plus z by c is equal to 1. Remember that. So as a fifth one, equation of the plane passes through the intersection of the plane, passes through line of intersection of the plane. So its vector form is vector r dot n1 plus lambda times n2 equal to d1 plus lambda times d2. So remember, we in last class we derived 5 important, very important derivation. So last video only these 5 derivations. So please remember, all the 5 derivations are important. You will get 1 derivation out of this in exam for 5 marks. Usually the first one. Okay, very important is first one, then you may get one of these remaining 4 also, so be ready for that. But usually to the first one, derive equation of the plane in normal form. Derive equation of the plane in normal form anta exam keltare, uldadu barbad antenilla because ella textbook alli ide. So last class alli idu derivation kalditu, please okay work more because these are very important. Okay, so next equations of the planes are over. Now we have some properties of planes. Okay, relation between the planes, relation between the side line and the plane. Okay, relation between the lines. So we have some properties of plane and straight line. We are going to discuss about that. Okay, next the derivations are the exam point of view important alla, but okay, derivation. Okay, I'll show you in a board. If you're interested, learn. Otherwise, just learn the result. Okay, remember the result. Result is very important. So result already sikkim plane alli 5 results and straight lines alli 2 results. So total 7 result. Out of 7 result, 100% sure question. Okay, as a question number 48 maybe, so 46 maybe, you will get 1 question out of these 7. Adal doubt illa. So okay, next one, it's a one condition. Okay, condition for the coplanarity of lines. Okay, this will help you to identify whether the 2 lines belongs to the same plane. This condition will help you to identify whether the 2 given lines belongs to the same plane. So same plane lines and same plane vector and coplanar vector. Okay, here I am not talking about the vector, I am just discussing about the coplanar lines. Remember that. Okay, so consider 2 lines. Vector r is equal to a1 plus lambda times b1 and vector r is equal to a2 plus mu times b2. So consider 2 straight lines in vector form. Okay, let it be they belongs to the same plane and they're coplanar. These 2 lines are coplanar and they belongs to same plane. You know that, okay, here a1 represent position vector of the point which is belongs to the line L1, b1 is a vector which is parallel to line L1, a2 is a position vector of the point which is belongs to L2, and b2 is the vector which is parallel to L2. Okay, now using this condition we can obtain the condition for coplanarity. Okay, so observe carefully this diagram. This is a point A with the position vector A1. This is a point B on the line L2 with the position vector A2. Then this is A2 and A1. Join them, okay, and you will get a one vector as vector AB. Yeah. Now observe this carefully. This vector, okay, must be perpendicular to B1 cross B2. Remember, B1 cross B2 or B1 B2 are not parallel. They are vector which is present in the plane. So you know that the cross product of these two vectors will be always perpendicular to both B1 B2. So cross product will come out from this plane. B1 cross B2 will come out from this plane, like perpendicular it will come out. So AB will be always perpendicular to B1 cross B2 only if the two lines are coplanar. If two lines are coplanar, remember that vector AB must be perpendicular to vector B1 cross B2. Okay, diagram will explain everything, so confusion have a chance. So this is a vector AB, vector B1 cross B2 will be the like this. Okay, come out from the plane as a perpendicular vector. So ಎರಡು line coplanar ಆಗಿರಬೇಕಾದ್ರೆ ನೆನಪಿರಲಿ vector AB must be perpendicular to B1 cross B2. So what is vector AB? A2 minus A1. Why? Vector AB can be written as, okay, vector OB minus vector OA. OB andre position vector of B, OA andre position vector of A. Both are known from the equation of the straight line. So vector AB andre A2 minus A1. Since they are perpendicular, that dot product is 0. So A2 minus A1 dot B1 cross B2 is equal to 0. So this is a vector form condition for the coplanarity of the lines. Idana ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡೋದಿಲ್ಲ, ನಮಗೆ ಬೇಕಿರೋದು Cartesian form, because this will be used very easily to check whether the two lines are coplanar or not. But remember, suppose example ಕೇಳಿದ್ರೆ derive condition for the coplanarity of two lines, then you have to derive like this in vector form, and I will show you how to get in Cartesian form. So ಅರ್ಥ ಆಯ್ತಾ? ಕೇಳಲ್ಲ, but ಕೇಳಿದ್ರೆ ರೆಡಿ ಆಗಿರಿ. Okay, it means very simple derivation, ಇಷ್ಟೇ ಬರೀರಿ ಸಾಕಾಗುತ್ತೆ. Okay, remember, you may get but not a sure question. Understood? So this is a condition for the coplanarity in vector form. Okay, so now I will explain how to get the Cartesian form condition for the coplanarity of the two lines. Okay, so let it be A1 is equal to like this, x1i y1j plus z1k, B1 is equal to A1i plus A2j, B1j plus C1k, vector A2 is x2i plus y2j plus z2k, and vector B2 is equal to A2i plus B2j plus C2k. Now consider A2 minus A1 dot B1 cross B2. Okay, definitely this is a scalar triple product of three vector. Which are the three vector? A2 minus A1 will be the one. Okay, this is the first one. Vector B1 will be the second one. Vector B2 will be the third one. So it's a scalar triple product. Okay, vector detail agi discuss ಮಾಡಿದ್ದೆ. What do you mean by scalar triple product? So vector A2 minus A1 dot B1 cross B2 is nothing but determinant. Why it is a determinant? Because it represents scalar triple product. So nenpidella scalar triple product definition. So first row will be the components of A2 minus A1. So ಇದನ್ನ subtract ಮಾಡಿ A2 ಮತ್ತೆ A1 subtract ಮಾಡಿ ಏನು ಬರುತ್ತೆ? x2 minus x1. Okay, x2 minus x1, y2 minus y1, z2 minus z1. So definitely it belongs to the first row. Next, the components of B1. Components of B1 are A1, B1, C1. Next, components of B2, A2, B2, C2. So it will be the second row and third row. Okay, since their dot product is 0, this determinant must be 0. So when two equations of the lines are given, write its determinant. Suppose its determinant is equal to 0, definitely two lines are coplanar. Two lines are coplanar. When two lines are coplanar, when the determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 will be is equal to 0. So remember that. So ಇದನ್ನ ಕೇಳಬಾರ್ದು ಅಂತ ಏನಿಲ್ಲ, because textbook ಇದೆ derivations ಇದೆ. So be ready if it is asked. Easy ಇದೆ, ಏನು ಕಷ್ಟ ಇಲ್ಲ. ಅರ್ಥ ಆಯ್ತಲ್ಲ ಡಿರೈವೇಷನ್? ಸೊ ಎರಡು ಫಾರ್ಮ್ ಅಲ್ಲೂ ಡಿರೈವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ, ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಕಾರ್ಟೇಶಿಯನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಡಿರೈವ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಸೊ ಇಫ್ ಇಟ್ ಇಸ್ ಆಸ್ಕ್ಡ್, ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ಫಾರ್ 5 marks. ಅಗೇನ್ ಇದು ಕ್ವಶನ್ಸ್ ಬಂದ್ರೆ 5 marks ಕೇಳಬೇಕು, ಬೇರೆ ಅಲ್ಲಿ ಆಪ್ಷನ್ಸ್ ಇಲ್ಲ. Okay, so I hope you understood what is the condition for the coplanarity. Now, we are going to find out angle between the two planes. In last class or in a straight line we did this work, right? Angle between the two straight lines. Almost similar to that, we are going to find out angle between the two planes. We are not going to use any device. We are using one of the very simple result from the vector to get the angle between two planes. So I'll define first. Simple agide, very simple work. The angle between two planes is nothing but angle between their normal vector. Nenpili, carefully. The angle between the two plane is nothing but angle between the two normal vector of the plane. See, for every plane you can determine the normal vector. So you don't, okay, for example, this wall will be considered as a one plane. If I keep another, okay, my hand like this, I consider another plane. Illinda one vector barate, illinda one perpendicular vector barate. So if you want to find out the angle between the two planes, it is equivalent to finding the angle between the normal vectors of the plane. If you are able to decide the angle between the normal vectors of the plane, definitely you will get the angle between the planes. So whenever you want to find out angle between the planes, you find out angle between normal vectors of the plane. Angle between normal vectors of the plane. So please remember that, okay? So now suppose if you know the equations of the plane, how you can get the normal vector. Once you get the normal vector from the vector concept, we have one easy method to find out the angle between them. Okay. Consider two vectors, consider two planes like this. Vector r dot n1, vector n1 is equal to d1, vector r dot vector n2 is equal to d2. Then which is a two normal vector? This is the normal vector of the first plane, this will be the normal vector of the second plane. Okay, so according to the definition, angle between the two plane is nothing but angle between the two normal vector. And in vector chapter you studied angle, how to get angle between the two vector. How formula? Cos theta formula, a dot b by their magnitude. So if n1 and n2 are the two vectors and you're going to find out angle between them, and definitely you are using the formula cos theta is equal to vector n1 dot vector n2 divided by magnitude of n1 into magnitude of n2. Idenu hosa formula alla ನೀವು vectors allu kaltidiri, straight line allu use ಮಾಡಿದ್ದೇವೆ. So definitely this work is not new for you. Only new thing is angle between two plane is nothing but angle between the two normal vectors. So please remember that. So once you identify the normal vector from the given equation of the plane, it's very easy to find out angle between them using the formula cos theta equal to vector n1 dot vector n2 divided by their magnitude. I hope you understood. So angle between the two planes and angle between two normal vector. Right, next one more concept. See, maybe in the last class also I told that I will take all the theory part together, okay, then I will discuss the problems. That is the actual pattern. So in between, if I discuss the problem, exam al kasta agate because identification problem agate, yava formula ki yava problem anta artha agalla. So ella theory admele problem discuss ಮಾಡೋದು better, okay? So for that reason I will take one more concept, that is distance of a point from a plane. Distance of a point from a plane. So even in first PUC we learned this distance of a point from the line, perpendicular distance formula derivation. ನೆನಪಿದೆಯಾ? ಇಲ್ಲಿ derivation ಏನು ಇಲ್ಲ, one simple discussion ಇದೆ about distance of a point from the plane. Distance of a point from the plane, and it should be a perpendicular distance, remember that. Okay, so observe carefully, this is not derivation, this is not a proof for anything, just explanation. Example antu kedodu ella definite agi, but for answer nenpitkolbekagate, formula nenpitkolbekagate. If I give formula directly, you may not be able to remember easily, because if you don't know the reason, then it is difficult to remember. So with the reason I will explain, but this is not the proof. Okay, listen. So what we are doing actually, we are finding the distance between the point and the plane. Distance between the point and the plane. So consider a point P with the position vector a and the plane pi 1. Okay, so let it be, this is a pi 1, or you can consider this also. Okay, this is pi 2, this is pi 1. Interchange because they are parallel. Okay, so consider a point P with the position vector a and the plane pi 1, whose equation is equation of the plane vector r dot n cap equal to d. Vector r dot n cap is equal to d is the equation of the given plane, and point P will with the position vector a. So now we have to find out distance between the point P and pi 1. So one small construction, okay, consider another plane that passes through the given point. So okay, so idu pi 1, okay, the equation vector r dot n cap is equal to d. Here illi already one point tagondagittu, and we are considering one more plane which passes through the point as well as parallel to the first plane. Passes through the point as well as parallel to the first plane. Okay, illondu unit normal irutalva, for every plane there will be unit normal. This same unit normal we can consider as a unit normal of the second plane, because they are parallel. When two lines are parallel, okay, this will be the normal vector. That normal vector can be considered as a normal vector to the second plane also. Okay, so the unit normal of one will be considered as a unit normal of the another one. So after considering another plane, the first unit normal will be considered as a unit normal to the first plane or the second plane also. Okay, remember that unit normal of the first plane will be n cap, or even second plane will be the n cap. So remember that. Therefore equation of the second plane enagutte unit normal enu n cap. It passes through the point P with the position vector A. We know unit normal mattu passes through point A. ಹೇಗೆ find out ಮಾಡೋದು? vector R minus vector A dot n cap is equal to 0. ನೆನಪಿದೆ ಅಲ್ಲವಿದು? unit normal mattu passes through the point ಗೊತ್ತಿದೆ. second derivation R minus A vector n dot is equal to 0. So this is the equation of the second plane, ಅಂದ್ರೆ pi 2. equation of the second plane is pi 2. ಇದನ್ನು simply dot product property use ಮಾಡೋದು. R dot n equal to A dot n. So idon nenpille R dot n equal to A dot n. So what does this represent? This represent the perpendicular distance, okay, from the origin to the second plane, from origin to pi 2. Nenpille this represent the perpendicular distance from the origin to plane pi 2. Is artha aayta hege band anta heli? This I hope you understood. This is using the second result of the equation of the plane, because unit normal is n cap, passes through the point P with the position vector A. So answer is vector R dot vector n is equal to vector A dot vector n. Artha aayta? Now as I told here, the distance ON dash of the plane from the origin is vector magnitude of vector A dot n cap. See this length R dot n is equal to d alva. So this represent distance, perpendicular distance from the origin to the plane. So ON dash andre e distance, ON dash, this is nothing but magnitude of vector A dot n cap. This distance represent magnitude of vector A dot n cap. Okay, now therefore the distance PQ and the required distance yavudu heli? Distance from the point P to the plane, and this is a required distance alva. This is a required distance. Then okay, this is a required distance. This required distance is equal to this distance because they are parallel to each other, n dash, and n dash is also equal to ON minus ON dash, because they are parallel like this. It will come like this. Okay, they are parallel. So PQ, okay, is also equal to NN dash, and NN dash can be written as ON minus ON dash. ON minus ON dash. ON andre no distance from the origin to the first plane, and we took the equation of the first plane as vector R dot n cap equal to D. So what is the distance from the origin to the first plane? D. Correct? And we come to know after simplifying that distance from the origin to the second plane is vector A dot vector n cap. So required distance PQ, therefore this required distance PQ is equal to ON minus ON dash, which is equal to magnitude of vector D dot n cap, vector D minus vector A dot n cap. So this is a vector form of the distance from the point to the given plane. But idana very rare agi use ಮಾಡೋದು problem ಅಲ್ಲಿ, because vector form usually ನಮ್ distance ಎಲ್ಲ ಅಂತ ಬಂದಾಗ, distance ಬಂದಾಗ definitely use ಆಗಲ್ಲ. So we are going to use actually the Cartesian form. So I'll show you now what is a Cartesian form of the distance from the point to the plane. Derivation ಇಲ್ಲ ಇಲ್ಲಿ direct ಆಗಿ ಆನ್ಸರ್ ಕೊಡ್ತೇನೆ ನೋಡಿ. So suppose the given point is P of x1 y1 z1. See Cartesian form ಅಂತ ಬಂದಾಗ ನಮಗೆ position vector ಬೇಡ, we need the coordinates. So let coordinates of P will be x1 y1 z1, okay, with the required point, and the plane equation is ax plus by plus cz is equal to d. Ax plus by plus cz is equal to d with the given equation of the plane. Then the perpendicular distance, see ನೀವು first PUC straight line ಅಲ್ಲಿ ಕಲ್ತಿದ್ರಿ, mod of x1 plus by1 plus c by square root of a square plus b square. ಅದೇ ತರದ್ದು ಫಾರ್ಮುಲಾ. The perpendicular distance, if you simplify, if you substitute the given data in terms of the Cartesian form, you will get this, that is ax1 plus by1 plus z1 minus d by root of a square plus b square plus c square. ಇದು ಹೇಗೆ ಬಂತು ಅಂತ ಯೋಚನೆ ಮಾಡಬೇಕಂದ್ರೆ derivation ಬೇಕಂತಿಲ್ಲ, but this is an important formula. When they ask distance from the point to the plane, definitely you are going to use this formula, ax1 plus by1 plus z1 minus d by root of a square plus b square plus d c square. So this is known as the perpendicular distance from the point to the plane. Artha aita? So today what we learned? Today we learned the condition for the coplanarity. We come to know how to get the angle between the planes, and also we understood how to get the distance between the point and the plane. Distance between the point and the plane is nothing but the perpendicular distance. Vector formula derive ಮಾಡಿದ್ದೇನೆ, Cartesian formula answer ಕೊಟ್ಟಿದ್ದೇನೆ, ಎರಡನ್ನು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಅರ್ಥ ಆಯ್ತಾ? So almost we completed the theory part of 3D geometry. In next class I am going to discuss the problem based on the phi derivation and these properties. Understood? Thank you.